Hello, my name is Mihaylov. I'm experienced software engineer and technical trainer, and today we're going to talk about objects and classes. It is an extremely important topic when it comes to object-oriented languages. Keep in mind that this topic is only related to those languages. In languages such as C or Lisp or even functional languages, the concept of classes is not present. So whenever you hear that certain language is an object-oriented language, it means that it supports classes and objects. So first of all, we're going to look at what is the difference between an object and class and how to use them. And this is going to give us the foundation on which we're going to build the later knowledge that we need. After that, we're going to discuss some already there API classes that we can use, and these classes were provided to us from the core developers of the language. They help us with everyday tasks such as random numbers, such as doing datetime calculations, as you might have already faced some of them. There is a class called datetime, for example, and we have already used it to solve some problems. We can also download things from internet using these built-in API classes, and we can also work with extremely large numbers, as you might have already faced the system.numerics namespace. We're also going to tell what namespace is, and you have probably used big integers. Finally, to wrap up our topic, we're going to learn how to define custom-made classes, derive objects from them, and conveniently use them to solve problems. And you'll see that classes are not something that hard to learn. They're merely a combination of primitive types into a compound data type. So they are sort of like data types defined by the user. They are used as a template to build something more sophisticated on top of them. Now, before we dive deeper into the topic, practice, practice, and practice. This is the key to grasping the content of this section. By practicing creation and usage of classes and objects, you'll learn how to use them correctly and how to derive most of them. Let us now continue with the first subsection of the topic. In this section, we're going to talk about objects and classes. First of all, we're going to define what an object is. And then we're going to define what a class is. Finally, we're going to look at some ways to use them in our everyday life as software engineers. So what is an object? First of all, an object is just a set of named variables. What does this set looks like? Well, as you can see here, we have an example of a birthday object. This birthday object has day, month, and a year. Now, why do we need these objects? And particularly, why do we need grouping and naming variables together? Well, if you want to model real life things such as cars, such as buildings, people, it doesn't really matter, animals, what exactly, but if we want to model real life things, we would need some way to capture the data together. And let's say we're creating this animal shelter application, and we don't really want to have scattered variables all around our program. Combining these variables, combining related variables together and labeling them, we create objects. And it's way easier to work with objects than plain variables. And as you can see here, we have a birthday object that holds day, month, and a year. Now imagine if we had three variables, day, month, and a year. This is way worse to work with than having a single birthday object that labels them in such a way: day, this is our day variable; month, this is our month variable; and year, this is our year variable. Now we can refer to them as compound object called birthday. And imagine we want to have tens and thousands of birthdays. Working with 3 independent variables is way more inefficient than working with a compound birthday object. This is the reason that objects, which are just a set of named variables, exist in the first place. Now, an object has a name, and the object has properties. So each object, in order to be object, it needs to have properties and names, or just a name. It needs to have a single name and many or 0 properties. It can even have 0 properties. That's completely fine. But I doubt that it's going to do any use. It's going to be of any use. Okay, now an object in C# is created using the new keyword. Whenever you are creating an object without using the new keyword, you won't be able to. And in this example, we have an object of type datetime, and we're going to look at these data types in just a second. An object of data type datetime, and this object has 3 properties. It has a year, it has a month, and a day. And as you can see here, we encapsulate these set of numbers, or we capture these numbers into a set of named variables, and we use them as an object. Okay, so we no longer have independent days, independent integer for days, independent integer for months, independent integer for years. We now have this compound object called birthday, and we can use it freely to do any kinds of date computations, even stored information. Doesn't really matter what you use them for, as long as they're helpful to you. Okay, now as I said, this new operator or keyword needs to be there. If it's not there, the compiler just won't allow you to create a birthday object. Why? Well, it's more of a compiler specific thing. Okay, now what is a class? And classes are closely related to the data type datetime here. There can be different data types instead of datetime, but what is a class? It's closely related to this datetime object, this birthday object. Now, a class is a way to provide structure to these objects. It's a template. Without this template, you cannot create objects. And this template is just like a data type. So if you have a car class, you can create many car objects. Each car object is just a set of named variables, but the way these car objects are created is through this template, which we call car class. And classes usually define data or properties and attributes. And let's see this for example, we have this car class, and as I said, classes are only templates or ways to structure data together. If we have this car class and we say, okay, in order to create a car object, this car object needs brand name or manufacturer, it needs color, it needs model, it needs tires, and a lot of stuff, a lot of variables, a lot of data together. So our car object needs these specific properties, the specific data. Okay, so having a class is just an abstract template. And from this abstract template, we can derive many concrete examples of cars. So we can say, I want to create a new car that has brand name of whatever, it has color of red, it has model XS, and it has 4 tires. And this is just an example. But I can create another car that has 5 tires. Each car needs to conform to this specification, to this template, to this car class. And we can do even more things using classes. We can define particular actions that each object derived from the class needs to support. And we have already seen such classes that define both actions and data set or data template. Such an object is the datetime object. So imagine now we have this datetime class. We already call them classes. We saw the datetime before, but we didn't really know what it means. Now we know that datetime is a class. And the object that we specified is of type datetime. Is derived from this template, from this class. So datetime is a class, and datetime has day, has month, and has year. Keep in mind that datetime is nothing concrete. It's just an abstract thing. It's an abstract template. So the core developers that wrote datetime, they told us, look man, if you want to work with dates, we can provide you with this template through which you can create objects that have some defined behavior and some defined data inside. So each object, each concrete object, so if we have this datetime here, this datetime class, the month is an integer, year is an integer, we have this datetime class, and everything is abstract. So we know that if we want to create a datetime object, we would need 3 integers. It doesn't matter what these integers are, we just need 3 integers. It is mandatory that we have them because this is the template. We need to follow the instructions, the specifications of the template. So whenever we create datetime objects, such as birthday 1, birthday 2, I misspelled it, birthday 2, these objects, these concrete objects that are of type datetime, need to have these concrete variables inside them. They need to pack this information that is required by the template. So we know that by being objects from datetime, they all have day, they all have concrete month and concrete year. The data stored in these objects is no longer abstract. It's a concrete example, it's a concrete representation of the class. So we can have a birthday that has day of 5 as a month of 12, means 5th of December, and we have year of 1998. Okay, so this is a concrete representation of a class. It's an object of type date time, and it's an object of type date time because it conforms to all the rules that are written inside this template we call class date time. Now, as I said, objects or classes can also define behavior. Instead of only defining properties and attributes which a certain concrete object needs to have, classes, the templates, can also define specific behavior. And this behavior can be, for example, add days, subtract a date, and this is an example for the date time behavior we can have. Imagine we have the same date time class. This is class date time. This is the template. This was the template. But now we also have behaviors such as add days. We have behaviors such as subtract another date time object. Okay? So we can add days to date time objects. We can subtract. And if we have two birthdays, birthday 1, we can say birthday 1 add days 5. And the birthday 1 object, because it's of type datetime, it knows that it can behave in this way. It can add date, or it can add days to its days. And if we define other arbitrary behavior, such as, let's say, get days or get year, we can say, okay, birthday 1, I need your year. Give me your year. Or create a duplicate or something like that. It doesn't really matter. So classes are just templates that define some specific behavior or data that a certain object needs to have. Classes are always, like, the template is always one, so you have one class, and from this class you can have numerous, like infinite amounts of objects that come from this template. Okay, so you can have class car, which defines specific behavior for a car. Let's say drive miles, and specify how much miles you want to drive with this car. Let's see an example here. We have this car class, and this car class is just one. We have one car class. This car class is the template. It defines what we need to have inside our car objects. So first of all, we need the data. And second, we need the actions or the behavior. Let's say our data is the manufacturer. Our data should contain the model of the car and the color. At the same time, our specific car object needs to know how to drive miles and how to repair itself. Okay? So it's sort of a self-repairing car. But everything is possible when using objects. You can combine data in various logical ways, and you can combine behavior that suits your needs. Now, as I said, one class, for example, the class I just created, the car class, can have many concrete representations. Concrete ones, not abstract ones, but concrete ones. Concrete representations that have various or different data. So we can have car that comes from Ford manufacturer. It's a model, I don't know, whatever model it is. And we can have different car that comes from different manufacturer, such as Volkswagen, and have different model. Let's say Golf 4, something like that. And an example of such class in C# is the datetime. So we have only one class, datetime. The datetime class is just a template from which we can create concrete datetime objects, which represent different years, different dates, different time spans. It doesn't really matter. Okay, an example of concrete objects from the datetime class might be Peter's birthday, or Maria's birthday, or someone else's birthday. Basically, we can have different objects representing different things. At the same time, these objects, if they follow from the same template or class, they have only one specific structure. And the key takeaway here, before we see the difference between a class and a object, is that classes are the templates and objects are the concrete representations of these templates. And we can have many representations of the same template. Okay? So imagine you're baking, let's say, cookies with the same form. It's a star form. Okay? But at the same time, we can have different color cookies. Okay? So if we have this plate of cookies, of dough, we can have different pieces here, and we have a star form which we use to cut the cookies. And cutting each cookie in a star form, now my drawing skills are not that great, but it doesn't really matter as long as you understand what happens here. So we have the same thing here and the same thing here. These, all of the cookies that we cut using the star form, they're the same shape. Okay, so they are from the same class. At the same time, they can be different color, different taste. And if we define this class, we'll say, okay, the class cookie needs to have form, or let's say star cookie. This cookie needs to have taste, and this cookie needs to have color. And we can have the same shape cookie, the star cookie, but different flavors, different tastes, and different colors. As simple as that. Okay? Things will get more clear after we work with some classes and objects. Now, what is the difference, the core difference? Classes, for example, we have the datetime here. The datetime specifies a datetime object. This is the template for a datetime object. We have a day, we have a month, and we have a year. And this datetime object, this datetime class, specifies the following behavior. It has add days and subtract days, or subtract dates. It doesn't really matter. And the class has a name, it has properties, and behavior. Now, objects are concrete representations of these classes. We have the Peter's birthday, which is a concrete example of datetime class, and it has day. This is a concrete day, not an integer, not just an integer. It is a concrete day, concrete month, and concrete year. So this is 27th, 11th, 1996. Okay? And another object, this is the Maria object, Maria birthday object, which is also of type datetime. And here we have day, which is instead 14. We have a month, which is instead 6th month. And we have a year that is 1995. Okay? And each of them has a name, and each of them follows the specification from the class. It has this defined set of variables that are mandatory, that should be supported by every single class or every single object of the class. Okay, now a more concrete example we can see in our IDE. In our IDE, we have the Peter birthday object and the Maria birthday object. And as we said, objects are defined with the new keyword. Okay, so this is the keyword that specifies that these objects are going to be of type datetime. Now, you can think of objects and classes just like custom-made variables, custom-made data. Now, classes are custom-made data types, and objects are variables of these data types. And we have here two datetime objects. One of them is 1996-11-27, and the next one is 1995-6-14. And as you can see here, we can print them, and running the program will get us the result of this right line. So we have Peter's birthday is 27th November, and Maria's birthday is 14th of June, 1995. What we can also do is add days, months, and years. This is a defined behavior of the datetime class. So we have another line here, another datetime variable, Maria at 18 months. And we simply need to add 18 months to Maria's birthday. Adding them will give us the result, or the year, the exact date on which Maria will be 18 months old. And after that, we can have the difference between Peter and Maria's years. So if Peter is 18 years old and Maria is 17 years old, we can calculate that difference using the subtract behavior of the datetime class. And by the way, the datetime class returns another variable type called time span. Whenever we subtract data or dates, we get a time span, an object of class time span. And this class time span has days. Okay? Running all of this, we can see that Maria at 18 months, the exact date was 14 December 1996. Exactly 18 months after Maria was born. And Maria is older than Peter by 532 days. Now, the first result here we got out of adding 18 months to Maria's birthday. How did we add that? Well, basically, datetime has this behavior of adding dates together, or adding months to a date. And the latter example, Maria is older than Peter by 532 days, we got by subtracting Maria's birth date from Peter's birth date. And by subtracting, we got this time span object which had the property of days. So it basically calculated for us the time span between the birthdays, between the birth dates. Okay? Now, you can play around with this. I encourage you, play around with a datetime object, and this will help you understand what happens if you still haven't. The first problem that we are going to solve using the datetime object, or solve using any classes or objects at all, is going to be called day of week. So you're given a date in format day, month, year. And we need to calculate and print the day of the week in English. So we get certain date, like this, 18/04/2016, 27/11/1996. And we need to get the exact day of the week in English. So how do we do that? Well, let's see here. We remove this because we don't really need it. And we take the input from the console, which is the simple date represented as a string. So date, we get console read line, and this is the date that we get. But the thing is that if we want to work with the string date, we need to do some hardcore logic that will allow us to print what day of the week it is. Instead, we're going to use the datetime object, which is significantly going to improve our program. Why? Because datetime object already has this behavior encoded in it or built in it. Now we say datetime date, and we say datetime.parseExact. What parseExact does, it takes string as an argument, which is the date, the string representation of the date, and it parses it in exact way. So if we get things like 08/09/2018 and 8/9/2018, the parseExact will know how to parse exactly this template here, this string representation. And first of all, we need to pass the date, and we need to pass something called a format. So what is this format? Well, this is the format of the date string that we'll get. And if for some reason someone passes an incorrect format in the console, on the console, the program will cease running and we'll get an error. So if we say our exact date is going to be day, month, and 4 characters for year, and we need to specify something here called string, or it was global dot provider, or something like using system dot globalization, and we needed provider I format provider dot string culture info invariant culture. Okay, so basically what we need here is to say that this date is going to be of type invariant culture. So the date is independent of any culture. Why do we need that? Well, basically the object itself, this type of behavior, the parse exact type behavior, it needs a specific culture reference, because different dates may have different representations, or different cultures may have different representations of dates. For example, in Bulgaria, we have different representation of the date, as in Germany, as in the United States, as in other parts of the world. This is why we need this culture info dot invariant culture, to say that we don't adhere to any specific culture. And this culture info comes from system.globalization. Okay? Now, what we need to do here is say console write line datetime date dot day of week. Okay? After we have parsed the date, we already have this built-in variable, this built-in property of the datetime object that is going to give us the day of the week. And now if we go back and take one of the inputs, which is 18/04/2016, we get 18/04/2016, we get Monday. How did this happen? Well, first of all, as I said, we take the input from the console and we define a datetime object, and we use the parse exact behavior of the class to parse the datetime or the date string using some format, some template, and culture info. As I said, culture info, the one we specified, is invariant culture, which means that we don't adhere to any specific culture. And the template that we have is day, month, year. What happens now is we can say month, day, year. And this way, you'll see that supplying 04, or what it was, 18/04/2016, we say the date time represented by this string is not supported in calendar. Okay? But if we do this, if we say 11/04/2016, we get Friday. Okay? And now if we change the template here and say that the day is going to be first, and we do the same thing, 11/04/2016, we get different day. Why? Because the first time our template was month, day, year, and we have month here, day here, and year here. But on the second go, with second run, we had day, month, year. And now the month becomes the day becomes the month, and the year becomes the year. Okay, so be careful with these formats. This is how we solve this problem. In order for you to understand better classes and objects, please practice more. Find other problems and try to solve them by creating classes or by using existing classes such as the datetime and creating objects from them, thus solving the problem. In this section, we're going to look at the built-in API classes in C#. Now, classes that we have already seen, such as the math, the random, the big integer, classes such as these have been created by the core developers of C# for us to use. Now, we're going to explore the way we use them and the different types of classes that the C# language provides. First of all, it conveniently captures the classes into namespaces. And such namespaces we have already seen. We used the system.collections generic namespace when we were working with dictionaries and other data structures. All of them are packaged under the namespace system.collections generic. We have also the system.collections. We have the system.link, system.text, and as you might remember, the system namespace here is whenever we need to call some system function like printing out to a console or reading from a console. And system text provides us with a way to work with different strings. Even we can do regular expressions and stuff like that. Also, system net provides us with networking capabilities inside the C# language. Now, if you're still not really familiar with what a namespace is, let us create another class here and make it a little bit more obvious. So I go here and create a new class. Let's create a new class here, call it test class or test namespace, testing namespaces. And you can see here that I created this class, which is called testing namespaces. Now, the namespace is just a way to package different classes together. It's like an import statement in Java or like a import statement in Python, and basically just packaging code together. Now, as you can see here, we have two equal namespaces, or two of the same namespaces. We have namespace application, and here in our main class we have also namespace application. But as soon as I change this namespace, let's call it test namespace, and I define some classes here, we can define multiple classes in the same namespace, and even in the same file we can have different namespaces. We can say, or even sub namespaces. We can have namespace test or subspace. Let's call it subspace. Let's create another class, test subspace class. Okay, so we can have this structure here, and this means that inside the test namespace we have another namespace which packages different things, and we can see that in a moment. So first of all, I'm going to define two classes. Let's say testing namespaces 2, and as I go here, if I say, okay, I want to use the testing namespaces 2 class and create an instance. Let's say we have two constructors here. So say testing namespaces 2, copy this, go here, say, even though we're going to get default constructors anyway, we can say here testing namespace or test subspace class. Okay, now in order to access these classes and their functionalities, we need to be inside the namespace, right? But here, as you can see, we have different namespace. So what do we do in this situation? Well, we can just say using the test namespace which we defined, and we can use everything that's inside the test namespace. We can say testing namespace space equals new testing namespace 2. And we can even define the only testing namespace class. Say new testing namespace. Okay? Now the two classes that we defined inside the test namespace, we can use them. But can we use the class that is defined inside the subspace? Can we use it? Pause the video and think about it. Well, the answer is no. We cannot really say test subspace or something like that. Test subspace class subspace new test subspace. As you can see here, it does not allow us. It says the type of namespace name could not be found. Okay? So what we need to do is say using test namespace, but now we are going to use the subspace. Okay? So we need to explicitly include everything that is inside the subspace. Now, the same thing goes for built-in namespaces like the system.collections, which we saw previously. So system.collections is one huge namespace comprised of different collections and interfaces. What can we do now is say collections.generic, and we get another set of different collections. And the difference between collections and collection generic is not that obvious, but it is way beyond our scope here. So we're not really going to discuss. Now, as I said, namespaces just package different code together. And they are used for just separating logically your code and making it a little bit more clear and a little bit easier to read. Now, the two different classes or two different utility classes that you have in C# are the static ones and the non-static ones. So what does a static class mean? Now, a static class is a class that we use directly without instantiating, without creating an object from that class. And you might actually already figure it out. You might have already figured it out, but we have a keyword called static here, which we talked briefly about, but we didn't really mention what is it for. And now we're going to explain it briefly. So first of all, I'm going to remove all of these namespaces here, make it the same namespace as our application. Remove this. Let's remove all of these because we don't really need them right now. And let's do this. Let's create only one class here and have it. This is a static class. Okay, so this is a static class. Now, this static class we're not going to use with instances. We're not going to create objects. So we define this template, but we're not going to create objects through which we're going to interact with the class functionality in the behavior. Now, what we can do is say public static, and static means that the action or the behavior is defined for the whole class, not for a particular object. It works with the whole class. So we can say static, and let's say print number. Let's give it a number, and say Zollright line the number. Okay. Now, what we can do here, static void print number. Okay. Now, what we can do now is instead of saying static class object or just object equals new static class static class, and then saying object.print. As you can see, we don't even have it here. We don't have object.print number. What we said to the compiler is that this method here, this action, this behavior is going to be static, which means that we don't need to instantiate an object or to create an instance from the class in order to use this print number action or method. What we can do is say directly static class dot print number and give a number. Okay, and now after running the program, we should get as an output the number 5. And this is what we call a static method or a static class. A class which doesn't really have, you don't really have to instantiate or create an object of this class in order to invoke some functionality. And as you can see here, we have the date time as an example. As you can, if you remember, we used something called datetime.parse, which is just a static method, a static action that was defined inside the datetime class. We can use static members, such as the datetime now, and we can use the math library or the math namespace, the math class, in order to statically calculate different things. And the reason here that we have math.cosine is because cosine is just a function that is inside this utility class. And because it's an utility class, we don't really need to instantiate it. We can just make it static and use it this way. We can say math.cosine, calculate some cosine, because cosine is just a universal function. We don't really need different objects with different implementations of cosine. So we have one class and different members of this class, different methods which are static, and we can use them and invoke them anytime without instantiating the class or creating an object of this class. Now we can go here and we can say even math dot, come on, then we have math. No, we don't. Okay, so we have absolute value, we have a cos, we have a sine, a tangent 2, big multiplication, ceiling, cosine, cosine h, different mathematical functions which we can invoke directly from the math class. And we don't have to say math2 equals new math. We simply don't have to do that because we don't want some functionality, some behavior depending on some object. These are utility classes, built-in utility classes. We can make them static and just use them throughout our application. Now, the next ones are the non-static classes. And inside C#, we have something called the random class. And the random class is just a way to create a random object which is going to generate random numbers and different interesting capabilities. So because it's a non-static class, we need to instantiate it. We need to create an object from this class. And I'll give you a little bit of intuition. Why do we need that as a design decision? And basically, these are all design decisions made by different C# core developers. Now, if we go here, we instantiate the random class, say random equals new random. Let's say random generator 1, say random generator 2. We can create two different random generators, random number generators or random sequence generators from the same class, right? So we have one class, which is the template, which is the random class, and we have two different objects of the random class. Now we can have different behavior for the different objects. We can say random generator 1 dot next. We can say from 5 to 100. Give me a random number in the interval between 5 and 100. We can say random generator 2 next from 100 to 150. Okay? And we can print out these random numbers. We say random number 1, random number 2, just print them out. Say rand or rand 1 and rand 2. We can print them out. And the thing is that now if we want to use both of these random generators, so these here, these objects that we created are just two random generators, right? If we would like to use two different random generators throughout our application, having only one static way of creating random numbers is not going to be that convenient. Why? Well, because these two random generators can take different seeds. So I could have different seeds, and this takes something else. So we can have a seed, we have an integer, we can have this one with seed this, and this one with seed this. So we have two different random generators instantiated in two different ways, which means that the behavior of the object is going to be different. Therefore, the behavior of the class itself, or the behavior of the actions, are dependent on the objects. So we have behavior that depends on the objects and needs to change with different objects. And if we have static classes, we have only one type of behavior, which is instance or object independent. It only depends on the class. Okay? So in the example with datetime.parse, there's just utility way to parse some data or some date into a datetime object. We don't really need to have to create datetime objects and then parse. It's just a nonsense. Okay, now as I said, in non-static examples, in non-static .NET classes, we have to instantiate or create an object of the class and then use this object member or this object method that was defined with the object, or this class method that was defined with the object. In the first example, we have a static member of the class which can be used directly with the class itself. And in the second case, we have an object which uses some behavior of the class. We definitely need an object. And we have another example here with the datetime and the math functions or classes. We can see them here. Now, first of all, we have a datetime object here. We create a datetime object from the datetime.now. So datetime.now is just a property of the datetime class. It gives us the current time. So this is the current time. And what we can do now is, after we have the object from the class datetime, we can invoke some specific behavior, tie it to the object. So it's specific to each object. If you say something like datetime.addDays, well, is this behavior defined? Can we define such behavior without making it so confusing for everyone to use it? I doubt that. How do we define addDays when it's not tied to a specific object? It's going to be pretty tedious work to do that, even probably impossible. Now, the next thing we can do is calculate the cosine of some angle. And we can say we have a 60-degree angle, and we get the angle, instead of degrees, we get it in radians, because math cosine accepts radians. and we can calculate using the static member cosine the actual value of the angle, of the cosine of the angle. And the reason we have, as I said, math.cosine instead of creating an object of type math is just because it's way more convenient. Finally, and it's a defined behavior. So you can just take some angle and convert it into cosine value. We can instantiate the random object, or we can instantiate an object from the random class, and using it we can create a random number, right? But if we just say random.next, this is not going to work. Well, we could have done that. This is a little bit more acceptable than the first one. But if we would like to use different seeds for the random numbers, and seed is just a starting random value from which we derive more values, if we wanted to use different seeds, it will be a little bit harder than that. We wouldn't be able just to pass around generators from method to method. Finally here, we have a web client. And web client is just a class defined in system.net. And what web client does, it can download something. So it could download PDF files. We can download a PDF using the web client. Okay? And we can say process.start.book.pdf. And just whenever we download the PDF, we just start it. We just open it. Okay? So if I comment this now, and if I open it, if I run the program, there's just a minor error. We don't need this. Okay, so now if I run the program, we get this. Today is this day, and tomorrow is this day. Okay, so add days is tied to a particular object, and the cosine of 60 degrees is 1/2, and the cosine of 60 degrees is always the same. So we can create a static member as it's done in the math class. Now try to practice more with the static and the non-static members of the C# classes. Find different applications of already built-in C# APIs and try to determine whether they're static, non-static, and figure out or try to figure out why these design decisions were made. Actually, try to have fun. Find a way to use APIs such as the web client, built-in classes such as the web client, and use their functionality. After we discussed about the built-in API classes inside C# that were provided us conveniently enough from the developers, now we need to solve some problems using them. And the first problem that we have is called randomized words. And this is actually a legit problem that we have in computer science. How do we randomize a sequence of things? Doesn't matter if it's numbers, if it's strings, or whatever. So we have a sequence of different things. And how do we randomize them or shuffle them, in other words? We have popular algorithms such as the Fisher-Yates shuffle, which do a pretty nice job shuffling different sequences. But now we're going to create a more simple algorithm to solve this problem. First of all, we're given a list of words. And here we're working with words, only plain text. And we need to randomize their order. So if we get something like 10S, 7H, 9C, 9D, JS, we need to just randomize them. Just
find a way to shuffle them around. How do we do that? Well, pause the video and try to figure it out on your own. Try to find a way using the built-in C# API classes, or try to find a way to solve them using the built-in API classes. I assume that you have tried yourself, and now we're going to work through this example together. First of all, we need to capture the input from the console. And the way we capture it is by using console readline, right? So we have a string array of words. We can say console readline, get the words, and split them by a white space, just to get each individual word. And what we can do now is we can say, whenever we get the words, just loop through them all. Okay, now we have this convenient loop, and we can use it to shuffle the words around. Now, how do we shuffle them? How do we find randomized positions inside the array? And the answer is using the random class. So saying random, your random, or as I'd like to do, is writing out the full name of the object, a descriptive name for the object. Say random generator, and we can use this random generator to generate different random places for each word. So if we have a sequence of words, let's say we have 3, this is 1, 2, and 3, take each one and find a new place for it. Okay, it's like having a deck of cards and just taking each card and finding a new place in the middle of the deck, just a random place. Okay, now think about how do we use the random generator we have now. Pause the video and think about it. The way we use such a random generator, as we saw prior to that, is taking the new position and saying random generator next, and we can give a domain, a closed domain, in which it will from which it will generate the random number. Now, if we use any domain from -infinity to +infinity, we're just going to get an index which is out of the bounds of the array. So if the number of words is 5, if we have 1, 2, 3, 4, 5 words, if we say generate a random number from -infinity to +infinity, we can get number like 32 or 1 million, something like that. And this is out of the bounds. So what we can do now is limit the random number, the domain of the random number. We can say, get me a random number from 0 to the word's length. Okay? And as you can see, returns next when supplied with 2 integers, the lower and the higher bound. It returns a random integer that is within the specified range. Okay? And now, as we have the new position, we can say words, string, old word. We need to swap out words, by the way, because the array, so if we have 5 words, we are always going to have a word on each place. So in order to take one word and have a new position for it, we need to swap them out. So here we're going to have another word, and we just swap them out using the random generator. So we say old string is equal to the words with index the new position, and we can say words of new position is going to be the words of E, and the words of E of the current index is going to be the old string. Okay, so we basically just swap out words. And now we can say something like print on each new line the words. Okay, and if we start the application, we can say something like word 1, word 2, word 3, word 4, word 5, word 6, word 7. And we can see here that instead of having them in order, we got them in a different sequence. So we have 6, 5, 2, 3, 7, 4, 1. And it seems perfectly random. The thing is that randomness is a whole another subject in computer science. So don't take the random number generator or the random class for granted. Think about it when you're using it, because if you try to use it in an application which deals with, let's say, money, it might not be beneficial to you, since there are different types of random number generators, different types of randomness, and you need to consider all that, which is, by the way, way beyond our scope. Now, here is the solution. We have the words. We take the words from the console. We create the random number generator from the random class. We just instantiate the random class. And as I said, we find a new position and swap the words. Okay, and finally print them. Now, this solution is almost the same as the one we did. There are probably different ways for solving this, as with any computer program or as with any problem, but this one seems to do the trick. Now, I encourage you, check out the Fisher-Yates shuffling algorithm. It might be interesting to you to see how it's actually done in the real world. The next problem that we have is calculating the big factorial. So calculating the big factorial means that we need to calculate a factorial of a big number. What was factorial? Do you remember? Well, factorial is a way to calculate everything from 1 to the number that we have. And in our case here, we have 5. So factorial of 5, or in other words, we can think about factorial as a function, and we need to multiply each number from 1 to 5. So we multiply each one of these numbers. But as you might imagine, as the number that we need to calculate factorial on gets bigger and bigger, the result of the factorial calculation is getting bigger and bigger. So how do we calculate a factorial of a number that is even higher than 100, even higher than 200, 300, 400, so forth, so forth? How do we calculate factorial of such a big number? Because as you can see here, the outputs are humongous. So we have these humongous outputs which we can never fit into a long data type. How can we do that? Think about it. Pause the video, try to solve the problem on your own, and after that we're going to work through it together. Okay, now I imagine you tried it yourself, and now we can use built-in libraries or built-in APIs in C# to solve the problem. First of all, we need to get the input. So the input is going to be a single number on which we need to calculate the factorial. Okay, so the number we get in this way. So it's a number int parse console read line, and we get the number. So what we need to do now is say for each number from 1 to less or equal to number, do something. Why? Because we need to loop and multiply every single digit that is in the domain of 1 until 5. So the lower bound is always 1 and it's closed. We have something like, if we have n here and we have factorial, our domain is from 1 to n, closed. So we need to calculate the sum or the product of each number from 1 to n. Okay? Now we need to loop in order to get every single digit. But how can we capture the result? How can we calculate the result? Is there a way? Pause the video and think about it. Can we use something that is built in C# to solve this problem? In other words, do we have a way to work with such big numbers? And the answer is yes. So first of all, we need to go and add a reference. And this reference is to a namespace. And this namespace we called system.numerics. We can see it here. So we have system.numerics. And system.numerics packages something really important when we work with big integers. And this is the big integer class. So if we go here and we can say using system.numerics, and we can now use the big integer class. And the big integer class we need to instantiate. So say product is equal to 1. Okay? We can say now product times equals e, and we can print it out. Now if we were using long here, we wouldn't be able to calculate everything. Simply because long is just 64 bits long. It's a little bit of a pun, but it doesn't matter. So long is 64 bits. Okay? And big integer doesn't really have a bound. So big integer is just a way to cram huge numbers. It doesn't really have a limit. The limit is probably only your memory and your computational time. So if we now say 88, we're going to get the result of the 88 factorial. So we multiply everything from 1 to 88. 1 times 2 times 3 times 4 till times 88. Okay? And we can even say, give me the factorial of 200. And here it is. This is the factorial of 200. This is how we work with big numbers inside C#, using the built-in big integer class. The thing is, you could write your own big integer class if you're fluent enough in programming, if you're a good enough computer scientist, but we have it already built in. So why do we need to reinvent the wheel? Well, we don't really need to. We can just use the already created API class or already created utility class. Now, we can see here that the solution to the problem is pretty much the same. We go to references, we go and add system.numerics, and finally we calculate the result and print it out. It's basically the same thing. I encourage you to go out and try to solve different problems that require built-in functionality and use the usage of built-in classes in C#, whether static or non-static, it doesn't really matter, but you need to solve even more problems in order to get used to all the built-in functionalities in C#. In this section, we're going to learn how to create custom-made objects instead of using the built-in ones. Now, the first thing is that a simple class is just a class that holds a few fields of data. Okay, so in this example here, we have a point which has an x coordinate and a y coordinate. This is a super simple class, the class point. And whenever we want to create concrete examples of this class point, such as objects, as we always do, we can say create a new point with coordinates 15, 12, or create a new point with coordinates 23, 7, something like that. So the first thing is that we need to have the definition. We have class point. This is the first step towards creating your own class. Now, after we have defined the name of the class, So we have the keyword class, the name of the class, and the body of the class, which is defined in curly braces. This is the class name, and we have the class properties. So this thing is pretty much exclusive to C#. In other languages, you're not going to see this definition, probably. If it's one that is motivated by C#, you might see something like that. But in C#, we have something called properties, and these properties are just ways to define data inside classes, and they're not really different than the actual data variables that we can use. But we'll see that in a moment. And we can define one more property, which is the y coordinate. So we have two properties, the x and the y coordinate, and these properties hold the class data. Okay, so whenever we instantiate an object of this class, whenever we create a concrete point, let's say on a 2D surface, because we have only two coordinates here, this point holds these properties hold the data inside the point itself. And now we can create a point, a concrete point, using the new keyword, the name of the class, the parentheses here, and we can define the data inside the class using the properties. Finally, we can write on the console the actual point using the properties by calling the properties. And the way we call them is we use the object name, we place a dot, and we place the property name. This way we extract data from the object and we feed it to the console, or we output it to the console. Now, if we come here, we can actually create this point class. We don't really need these anymore. So disposing of these, we can add a new class, new item class. We can say add a point, and this is our point class. Now there isn't really a big difference between saying private int x, private int y, and saying public, or let's make them public so it's not confusing at all. So we say public int x and public int y. This is pretty much not that different than saying public int x and giving it the get and set here, and I'll explain what this means in a moment, and saying public int y and saying get and set. You can do the same thing here. You can say get and set. It's the whole, it's the one and the same thing. Now, why do we place the get and set keywords here? The reason is that having the get and set keywords, we can actually use the properties outside the class. But if we say something like private set, we can no longer use the properties or change the properties. We can no longer change the properties. We can only read them. And get here stands for retrieving the value, and set stands for changing the value. But these things don't really matter right now. The only thing that matters is this is the way we define a property in C#. And in properties inside classes, we keep our information. And we can say something like public point here, like this. Okay? Now, having such a point class, we can instantiate different points and output them on the console, or do different calculations using them. Okay, now that we learned how to create a simple object from a simple class, we can transfer to a little bit more complex example, and we have a problem to solve right now. The problem is called distance between points. So how do we calculate distance between arbitrary number of points? First of all, on each line in the console, so we have two lines on the console, two inputs on two different lines, and each line contains a point. So we have 2 points that are going to be supplied to us by the user. And we need to calculate the Euclidean distance between these 2 points. Or in other words, if we have something like a Cartesian coordinate system like this, and we have 2 different points laying somewhere here, let's say this is x1, x2, and this is y1, y2. These are points. Euclidean distance is just the distance from one point to the other. And we need to create a program that is going to calculate for us the Euclidean distance between 2 points. So how do we do that? Well, first of all, it advises us to use this type of method. We need to create a point class, which we already have, but we also need to create a method called calculate distance between 2 points. So this method needs as an argument 2 points. How do we solve this problem? A little hint that I can give you is you can search in Google about Euclidean distance. Find a way to calculate it using the coordinates of the points and some basic mathematical transformations. Try to solve this problem on your own. Now, you might have already tried to do that, and we're going to go through it together right now. First of all, we have the point class. We already created the point class. And what we can do now is we can create 2 methods. One of them is going to be called readPoint. And readPoint is just going to help us parse a point from the console. So we can say something like point static point read point. Then we can say, and by the way, as you can see here, the return type of this read point method is a point. So we get a point object from the read point method. And what we can do now, let's just for now return null. What we can do now is say double get distance or get Euclidean, I hope I spelled that right, distance between point 1 or point left and point right. Okay, so get Euclidean distance between points. Now what we can do, return something arbitrary here, is we can say, okay, now we need 2 points from the console. We need to expect 2 points. So we're going to write point left is equal to read point, and point right is going to be equal to read point. Now we need to define read point so we can read the 2 points from the console. And this is the first step of our application. How do we read 2 points from the console? Now what we can do here is we can say integer array is equal, or coordinates is equal to console.readLine.split by white space, parse the values using link, and create an array. Okay, so this is one of the easiest way to do that. We need to add system link. And right now we have the 2 coordinates of the point, which are going to be supplied to us separated by a white space. We can say point new point equals new point of x is equal to coordinates 0, which is the first parameter, and y is equal to coordinates 1. Okay, now we have 2 points, name coordinates. Okay, now we have 2 points or 2 coordinates which comprise the whole point, and we can return that point that we created inside the method to our main function. Now we have 2 points read from the console. What can we do with them? Well, what we can do is say console write line get Euclidean distance and give the points to the method. So what we do now is we rely on the get Euclidean distance method to calculate the actual distance between these 2 vectors or points. Now, as you can see, we had to declare it static. Why? Because we know that static members can be used without instances or objects. Otherwise, we would have to say program object equals new program and then say object.getDistance, which is pretty inconvenient, and we don't want that. This is why we declare them static, so we can directly use them without declaring or without invoking or instantiating the class itself. Now, what we can do here is calculate the Euclidean distance between the left point and the right point. But how do we do that? I encourage you, search the Google. Use Google to search and find information about Euclidean distance. Okay, now what Euclidean distance is, as I said, is just a distance between 2 points. And the way we can calculate that distance is by taking the difference between the x coordinates. Let me just do it here. We can take the difference between the x coordinates, say x2 minus x1. We add to it the distance or the difference between the y coordinates. We square them both. So both of them have to be squared. This too. Okay, let me do it this way. So we have x2 minus x1, which is the difference in x coordinates of the 2 points. Each point has x1, y1. This one is x2, y2. And we can have x2 minus x1 squared. And squared is just because we don't want negative numbers. And we have plus the difference in y's squared again. And this whole thing is square rooted. So the distance between these 2 vectors is given to us by this formula. So we have the difference or the distance, basically it's just the difference between the x coordinates, difference between the y coordinates. We square them both, the differences, add them together, and take the square root of the whole expression. Okay, let us translate that into code. And we are going to give a little bit more intuition about this formula, but we're not going to deviate that much into mathematics. So what we can do now is we can say difference x, let's make it double, or okay, let's just make it integer. Difference x, you can say math, or well, let's say left.x minus right.x. You can say difference y, left.y minus right.y. And we can say calculate the math.square root. Math has a static method called square root, which just takes a number, a decimal number, and returns to us the result of the square root function. And we can supply to it the math power, which is another static function of the math class, which allows us to raise certain number to certain power. We can say difference x powered to 2 plus difference y powered to 2. Okay? Now, this is the result. This here is the result of our Euclidean distance method. And if we start a program and we go here, we see that we have 3, 4, 6, 8, and the result is 5. So if we go here, we have 3, 4, 6, 8, 3, 4, 6, 8, and we have input string is not in the correct format. Okay, let's go back a little bit and find that little error. 4, 6, 5. Oh, we got it. So we need 3, 4, 6, 8. And as you can see here, the result is 5. But what I assume here they have done is they have printed the result with 3 decimal digits, or 3 digits after the decimal point. So what we can do here is we can say, okay, instead of printing the plain number, print the number with 3 decimal digits after, or 3 digits after the decimal point. And this should be working pretty fine. You can say 3, 4, 6, 8. And I think this should be 2F3 or F3, something like that. 3, 4, 6, 8. Nah, not really. Oh, we forgot this. Okay, so 3, 4, 6, 8. Yep, we have 5.0000. Okay, so this is what Euclidean distance means. Just the distance between two vectors, which we calculate using some mathematical formula. Now, let us check the solution and give a little bit more intuition about the Euclidean distance. First of all, in order to calculate Euclidean distance, as you can see here, we have 2 points, which are x1, y1, and x2, y2. We can create, or we can connect a triangle here. And as you can see, in order to get the distance between them, the distance between them is equal to some side, just some side of the triangle. So this triangle is a right triangle, and because it's a right angled triangle, we know that this side here, let me do it blue, this side here, this one, is equal to c squared, and, or just c. And the way we calculate it is we take the square of this side, and the square of this side, or the distance between two vectors, is the square of one side plus the square of the other side. And we did this using the difference. So a here we can calculate using the difference in x coordinates. And y here we can calculate using the difference between y coordinates. So if we go and want to calculate the b side, we're going to subtract y1 from y2, or the other way around. And if we want to calculate the a side, we are going to subtract x1 from x2, or the other way around. Finally, after doing the calculations, we are going to square both of the sides. As we did, we square the difference in coordinates. We're going to sum them up, the square differences, and finally we are going to square root the sum. Why? Because without square rooting the sum, we are left with the square of the c side, and we want only the c side. So 25 is c squared, and in order to get c equals 5, we need to square root c, right? So we need to square root this expression here, in order to get the plain C variable. This is also what we call the Pythagorean theorem. Now, having this theory in mind, we can actually write the code. And as we did, we created a method that reads 2 points from the console, and after that calculates the difference and prints it out with 3 decimal digits after, or 3 digits after the decimal point. And the way we define the read point is we split the input from the console, we parse it into integers, and we create the new point. And we just return the point, the newly created point, back to the main method, or the invoker of the method. And finally, we calculate the difference, or the distance between 2 points, point 1 and point 2, using the delta x, which is the A side, the delta y, which is the B side, and finally, we say A squared plus B squared, which is delta x times delta x, which is just delta x, or the difference between x coordinates squared, plus the difference between y coordinates squared, and is the same as A squared plus B squared. Finally, we take the square root of this expression. Why? Because as I said, this here, this expression inside gives us C squared, or the distance between the vectors squared. And we need just to take the single one. So we square root it. Okay? And we get the actual distance between 2 vectors, or 2 points. And point and vector is the same thing, pretty much. Okay, now in order to get better at these problems, and in order to learn how to create more and more complex objects and use them, I encourage you, just try to solve as many of them as possible. Find other problems which require more complex objects, find other ways to use or create and use objects yourself. Even do your own research and do your own problems. Create problems for yourself, like let's say you want to create some application, use objects in order to create it. The next exercise that we have, instead of calculating the distance between 2 points, we need to find the closest distance between n number of points. So what am I talking about? First of all, the problem is called closest to points. And intuitively, we need to write a program that reads n number of points from the console, and this n integer is going to be supplied to us on the first line. This is the number of points that we have, and we need to print the closest 2 of them. So if we have, let's say, 7 points, we need to find the 2 of them that are the closest to each other. And you can see an example here. We have, in this one, we have 4 points. This is the first, this is the second, the third, and the fourth. So we have 4 different points. And we find the closest 2, and we print them out. So the closest 2 are 3, 4, and 2, 5, and the distance between them is 1.414. Now, fortunately, we already did something similar in the previous problems, and we can reuse some pieces of code from there. Now, I encourage you to pause the video and try to solve this on your own. I imagine you have tried it on your own, and whether you have succeeded or not doesn't really matter. What matters is that you have tried, and we can now work through this problem together. First of all, what we need to do is go to our IDE And as you remember, we already created a method that is going to read points from the console. And this is actually pretty cool because we can reuse it now. We can say, instead of having only 2 points, we can have n number of points. So number of points is going to be defined outside of our program. We're going to say console read line. And we do a for loop from 0 to number of points, and we read from the console all the points, and the way we store them is in an array. So we can say points, new point array with the size of number of points. Okay, and now we can say point at index e is going to be equal to read point. Now this is the way we capture our input. So we define, or we capture from the console, the first line, which is the number of points that we need to expect. We initialize a point array, and we need to loop from 0 to the number of points, and each time we need to capture each point from the line, and we do it. Now what we need to do is we need to say double, or we need to find the 2 points closest points. We need to find closest points. This is our new method that is going to find the 2 closest points, and is going to give them back to us. And let's define the find closest points method. We say static point array. So this method returns a point array, and we can call it find closest points. Copy this, paste it here just to be correct. And this array, for this array we are going to pass the points. Okay, so we have points, and we need to find, so we pass an arbitrary number of points, and we need to get back 2 points. Okay, so from all of them we need to get only 2. Now what we can use here is the get Euclidean distance. So the get Euclidean distance is a pretty nifty way, or a pretty nifty method, which we can include in our new method called find closest points. And the way we're going to find the closest 2 points is by using the Euclidean distance method to calculate the point between each, the distance between each single point, or each pair of points. Okay, so what we can do now is we can say get Euclidean distance is going to be used inside the find closest points. First of all, we need to allocate the array for the 2 points. We can say closest points equals a new array of size 2. So these are the closest points, and we can return them. So we can say return closest points. Now we need to find some way to extract the 2 closest points, put them inside this array, and return them back to the invoker of the method. So how can we do that? First of all, we need to define a variable called min distance, and the min distance is going to be equal to double dot max value. The reason here is that we need to find the lowest number, or the lowest distance possible. So everything is going to be lower than the max value. So whenever we encounter a difference that is going to be less than max value, we're going to capture it. And the next distance that is going to be lower than that, even lower, we're going to capture that next. And this way, we're going to go deeper, 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 and get the closest point. Now what we need to do is to create 2 for loops that are going to compare each point together. So imagine we have a bunch of points. Okay, so we don't really care what the coordinates are right now. We just have 2 or arbitrary number of points. We need to get each point and compare it with each one so that we find the closest to. In reality, such a problem might be solved using a more sophisticated algorithm, but now the one that we are going to create is going to do the work. And the one that we are going to create is one that takes every single point and compares it distance-wise with every other point. So we have two nested for loops. We say from E till points.length, E++, for J, 0J is less than points.length, J++, and we say point left equals closest points E, point right equals, or not closest points, we need the actual points. So we need the points J, and if left equals right, just continue, because we don't want to compare the distance between two of the same points. And what we can do now is we can say double distance, and we get the Euclidean distance of these 2 points. We can say get Euclidean distance, and now you can see that we actually use the method that we built prior to this, and this method gets the Euclidean distance of the left and the right supplied points and returns it back to us. And we can say left, right, and now if and only if this distance is lower than this distance, this is the cumulative distance, or the global distance, the global minimum that we need to find. If this inner distance is less than the global distance, the global distance is equal to this distance, and the new closest points are the left and the right point that are right now the inner ones. Okay, so that we are the left and the right point that are currently working here. We can say closest points 0 is equal to left, and closest points 1 is equal to right. And this is how we do it. Now, this thing should be able to find the closest 2 points and return to us the actual 2-point objects that are closest to each other. What we can do now is pass the reference for the array, or pass the array itself. We can say points, and we can say right line. So we need to output the distance between the 2 points and the points themselves. So we can do now is say print point and print the closest points 0. This is the first point, and we can say print point closest points 1. Okay, and now instead of creating the same block of code, which we're going to, like saying console write line 3 or 4 times, we can say it only once inside the static void print point method, which takes a point and prints it out. And we can say this is 0, 1. Okay, and we need to print the x coordinate of the point and the y coordinate of the point. And now, before printing the points themselves, we need to print the Euclidean distance between them, or the smallest distance between them, with 3 digits after the decimal point. We can say get Euclidean distance again between the closest points of 0, this is the first one, and closest points of 1. Okay? And this is how we do it. So basically what we did is we took the first integer from the console, which is the number of points. We created an array of points and we read them from the console. After doing that, we created an array or a method find closest points that finds the 2 points that are closest to each other in this array of points and returns them to us in the form of array. So we have left and right as a result here. Left point and right point, basically. And what we do after we find the closest points, we write the Euclidean distance with 3 digits after the decimal point, and we print out the 2 points that comprise the closest distance. And the way we found the closest points is we had to loop over each point. So we basically take each point, compare it to each other point, take the minimum distance, the minimal distance, and take the 2 points that created this minimal distance. And this is our algorithm that works here. Now, if we run the application, we should be getting the correct result. So we have 4, 3, 4, 6, 8, 2, 5. So we have 4, 3, 4, 6, 8. We have 2, 5, 2, 5, and we have minus 1, 3. And we get 1.4143425. Basically, 3, 4, 2, 5 are the closest points together, and 1.414 is the result or the Euclidean distance between these 2 points. And this is the result here. Let us try with another example. So we have 3, 12 minus 30, 6, 18, 6, 18. Let's try with this one. So we can say, run again, and do this. Basically, enter 3, enter 12 and minus 30, enter 6, or let's do it again because we failed miserably. So we do 3, we do 30, or 12 minus 30, 12 minus 30, 6, 18, 6, 18. And we get 0.000, we get 6, 18, 6, 18. Okay? Basically, we had one at the same point. And as you can see here, the answer is correct. We get 0000, 618, 618. Now, what we did was we created a method that is going to read points from the console, and we did that actually in a previous exercise. What we did after that is we created a method that is going to find the closest 2 points together, and we created 2 methods, or here they created 2 methods called print distance and print point, but we actually left this one out. It doesn't really matter. We could also create it, but it's not something significant. It's not a significant change to our program. What happens next is the read point method that we created previously reads the 2 integers from the line, or reads the 2 integers from the line and create a point object, return it back to us, and we do something with it. Okay? So we populate, using the read points method, we populate our points array, which are the points that are given to us from the console, and using the read point, we read each individual point. After that, after we're finding the result, we get to print the x and y coordinate of the 2 points that are closest to each other, and we print the distance between them. Now, the final piece of our code was the find closest 2 points together. So we have minimal distance, we have closest 2 points, which is an array that is going to be returned back to us after populating it with the closest 2 points. And this minimal distance here is equal or initialized to double max value, which is the maximum possible value for a double data type. And the reason is that when we loop through every single pair of points that we have, and we calculate the distance, we need to compare that distance to the minimum distance that we already have. So basically, if we have 5 pair of points, and the first 3 had a particular minimum distance between them, or particular distance, if we find another distance that is less than them, we just write it back. So we say, okay, we found another minimum distance, or we found a new minimum distance. We write it to our variable, and we save the 2 points that created this minimal distance. It's like finding a minimum or maximum integer, maximum value in an array. Okay? And finally, we return this array of closest points that we found. Now, try to solve more problems like these, which require a little bit more complex logic, and even solve problems that require more complex objects and classes. Have fun playing around with the problems you can find. In this last section, we're going to talk about class operations. And we're going to give this brief introduction to them and what can we use them for. So if we have this sample class here called rectangle, and this rectangle just represents a real life rectangle or algebraic rectangle or geometric figure, just a geometric figure. Now we have a top corner, we have a left corner, we have a width and height. Or this is the top left corner, the width, and the height of the rectangle. So basically, if we have a Cartesian coordinate system here, we can have a point, which is the top left point, and we have a height and some particular width. This is what a rectangle actually looks like. And this is a completely valid way to represent a rectangle. We basically just need a point and the width and the height. Why? Because we can reconstruct it. So we can reconstruct a rectangle from just the top left corner and a width and height. Now, what we also have here, which up until now we didn't really have, we didn't really know what is it about, we have something like an operation. It's a method, or is just a non-static member of this class. And let's see what this actually means. Now, as we know, static members of classes, if we have the word static here, we have static. This will mean that we can say rectangle.calcArea. And by the way, this is a completely fine thing to do. So you can have a static member or static method which calculates the area of a particular rectangle. But it is a little bit more confusing because you need to supply all the required data, or width and height. You need to have something like rectangle calc area and pass the 2 integers, 1 and 2. So you need to pass some information inside the calc area method. Without that information, since rectangle class itself doesn't really have any static data, each piece of data is associated to some object, we cannot really calculate the area this way. This is why we have an operation here, an operation which is non-static one. And what it does is it takes a particular object from the rectangle class which has already populated data here, which has already a defined state. So the object has a defined state, And this state of the object is merely represented by the variables here. So in a class rectangle, these variables don't have values. So they don't have values, they're just placeholders, they're just templates. And if you create a concrete object, now you have a state. And this object has data. And what we can do is declare an operation or behavior or action which will take the data, the particular data of the object, and will calculate the area. So if we create a rectangle here, let's go to our IDE, and if we create a rectangle, remove these things because we don't need them anymore. We go here and we say, okay, now I need to add another class called rectangle with properties top left, top, get set, copy this, paste a couple of times, say left, width, height. And if we have such rectangle, as you can see here, we don't have data. But now, if we say rectangle 1, and this is the object, and we instantiate this rectangle using top 5, left 6, height 5, width 7. And if we have such a rectangle, now this rectangle object holds some state. It has some state, and we can easily change the state by saying, let's say, change the left variable to 23, and this will change the state of the rectangle object. And having a static member here, static void, or let's say static double, let's make it int, static int calc area. If we have such a variable here, or such a method that calculates some width times some height, you'll see that this, or let's make it like this, width and height, you'll see that this is not possible, simply because the class itself doesn't really know what width and height is. It knows that an object needs to have a width and height, but itself, or it doesn't know what it means itself. So the object or the class here, the rectangle class, cannot calculate the area in this way. That's why we make it non-static member or non-static method. And the reason is that now whenever we call calculate area, we need to call it on a particular object. And as we know already, objects can hold state, and holding state means that they hold some data. And we can use the data of the object, the data, the width and the height, to calculate the area. So we calculate the area for a particular rectangle object. And if we go here, we can say right line rectangle 1 dot calculate area. Okay, and we should be getting result now. So we need to make it public. Okay, now we have the calculate area method, which gives us 35, and it's 35 because the height is 5 and the width is 7. So 7 times 5 is 35. But if we change the height to 12, or in other words, we change the state, well, we can simply recalculate the area. So basically, inside an object or inside a class, you can define a operation that will work differently on different objects. And these methods or operations have to be non-static, because as we already know, static members are tied exclusively to the class. So they use information that is stored within the class. Okay? Now, if we go back here, as you can see, this member here, this member method, as it's called, is not static. So it works on a particular object and uses the state of the object to calculate something or to do something. And this is what we are going to use to further solve more problems. Okay, now, as I said, this is the data, the properties that the class holds. And here they're undefined, so undefined variables. But if we instantiate this class, if we create an instance of this class, they will be defined. And we have the operations or the methods that the classes have. And you can define both static and non-static operations or methods. Static ones work on the class as a whole, and non-static ones work for each different object differently. So they use the state of the object to calculate something or do something. Now, another example of class operations we can see here. First of all, we have a method that checks whether a rectangle is inside another rectangle. And this is perfectly legit. So we can say, if we had the isInside method, we could say public bool is inside rectangle other. You can say return true. Okay, if something return true, blah blah blah. It doesn't really matter. For now, we return only true. Now, this isInside method or operation that is non-static, we can use it to check whether, let's create another rectangle, rectangle 2, new rectangle. Let's create top 7, left 1, height 3, width 12. And we can say, okay, is rectangle 1 inside rectangle 2? Or is rectangle 2 inside rectangle 1? Now, what this returns right now is always true. Okay? But if we had some logic that takes into account the state of rectangle 2 and the state of rectangle 1, it would be possible for us to calculate whether a particular rectangle is inside another one. Okay? And this is where member methods or operations of the classes help a lot. So it's some defined behavior for a particular class that can help us calculate or do some other stuff. Now, another cool example here is one with properties. So we have the bottom property and the right property. Now, in order to calculate the bottom and the bottom right corner of the rectangle, or the bottom left and the bottom right corner, you can have public int bottom, and we have public int. This is not the correct place to define these. So if we have bottom and right. Now, as we know already, top, left, and width and height. These are the 4 variables or the 4 pieces of data that we need in order to calculate everything else. So how do we define, or how do we calculate the bottom and the right? Well, first of all, the bottom of the rectangle we calculate by taking the top and adding the height to it. So taking the top and adding the height will give us the bottom corner, the bottom left corner of the rectangle. Or in other words, it will simply give us, if we have the top left corner, it will give us the side of the triangle or of the rectangle. And the right property, which is calculated on the fly. So as you can see, these properties they're not set by anyone. They're just calculated on the fly. And this one is just the left property plus the width. Let's see it in action actually. So if we go here, we just remove the set. So we don't want people to be able to change the bottom right corner. Okay, so in this example here, in this particular example, we would like people to change only the top left corner of the rectangle. So basically, if you have a rectangle here with this as a top left corner, if we want to change the position of the rectangle, we would like, let's say we would like to place it here, we would just have to specify a different point for the top left corner. And in this case, we specify a different point for the top left corner, and we get a newly calculated rectangle. And as I said, the way we do this is using properties. So as we can see here, we have the get and set for the property. We already mentioned what get and set means. Get means that we are taking the value from the top property, and set means that we are changing the value of the top property. Now, if we don't have a set method, basically these two get evaluated to some methods. If we don't have a set, we'll see here that if we say rectangle 1 dot bottom, let's say 5, this shouldn't be working. Okay, property rectangle dot bottom cannot be assigned to, which means that we cannot change the property of bottom. It's read only. And the way we can define a bottom property, or the way we can take the actual value out of the bottom, we can specify a return statement inside the getter. That's how we call it, the getter. So we say return top plus height. And here on the right, we say return top plus left. Was it like this? I think it was like this. Okay? So now we have two properties, bottom and right, which depend on other properties of the object. They themselves cannot be changed. Okay? So this is pretty important, because whenever we want to have a property, let's say, let me give you another context, another example in different context. So if we create a person class, let's say we have a person class, and this person has a string property which is called first name, and this first name has a get and set, and he has a, or she has last name, and we can set it and get it. Now what we would like to do is, instead of saying string full name and giving a way to set the full name, we can say, okay, now you know what, full name is always going to be constructed from the first name and the last name. So what we can do is say, whenever someone requests the full name, we can return this first name plus this last name. And we can omit the this for now. It doesn't really matter what it means. This just refers to the object that we are currently in. It's a little bit more complex. Whatever, just saying first name, last name. Okay? And we construct a third property from the first two that is always going to be dependent on them, and we're never allowed to change it for obvious reasons. Okay, now what we did here is we specified the top, the bottom, and the right, but here we need to change it to left. Left plus width. Okay? So in order to calculate the two sides, we need to get the top, which is this one, the x-coordinate, the left, which is this one, and we need to add the width and the height. So we can now really calculate these 2 points and even this one. This is how we do it. Okay? we only need the top left corner, or any corner anyway, and we need the width and the height of the rectangle. Now we can solve an interesting problem using these types of rectangles, and this problem is called rectangle position. We need to write a program that reads two rectangles from the console, and it reads its left, top, width, and height property, and print whether the first is inside the second. So as we can see here, the first rectangle, this one, is inside this one. So we have two rectangles, and the first one here, the first one specified 4 minus 3, 6, 4. This is the one. 4 minus 3, 6, or 4 minus 3, 6, 6, 4. This is the rectangle. And this rectangle is inside the second specified, this one. So if the first rectangle is inside the second rectangle, we need to print inside. And if it's not, we need to print not inside. So how do we check whether a rectangle is inside another rectangle? We already saw that. Try to solve this problem on your own. Pause the video and try to do it yourself, because we already faced most of the knowledge required for solving this problem. Okay, I assumed you tried to do it yourself, and now we're going to work on this together. So first of all, this rectangle object is going to be it's going to be pretty important for us, because we don't really have to rewrite the whole thing. We can use the already defined object that we have here. So for our purpose, we don't really need the area of the rectangle. We need to populate the isInside method. So how do we do that? Well, first of all, let's get rid of all of these things and read the two rectangles. Let's say create a method called static rectangle read rectangle. Okay, so we need to read a rectangle from the console and say rectangle left equals read rectangle, or rectangle first, rectangle second equals read rectangle, and we need to say right line, or let's say if first is inside second, we need to print out inside. Okay, and if it's not inside, we need to print not inside. Okay, so this is the structure of our program. It's pretty straightforward, nothing complex to it. The only more complex thing that we have to define is the inside operation that is specific to each object of type rectangle. But before that, we need to capture the data that is passed to us from the console. So how do we do that? Well, first of all, before you see me doing it, try to do it yourself. Pause the video and try to capture or try to populate the read rectangle method. Okay, now the first thing that we need to do is create an array. So we create an array of points or numbers. And we say console read line dot split by white space, and turn everything into integers, turn everything into an array. Okay, so we are reading the line, splitting it, parsing it, and converting it to array. Now what we can do is we can say rectangle new rectangle, or new rect equals new rectangle, and we can specify the top corner, which is numbers 0, the left corner, which is numbers 1, the width, which is numbers 2, and the height, which is numbers of 3. Okay, let us check whether we actually did this correctly. And let's tidy up a little bit our code, because as we already know, tidy code is a better written code than an untidy one. Now we can freely return this new rect object from our method. So we have this read rectangle method that will parse the input from the console, create a new rectangle object, and return it to us. Now the way that we need to read the values is that we have 4 minus 3, which is the x and the y of the top and the left. So we have 4 minus 3, and we have 6. So is 6 the width or the height? Well, as I see here, 6 might actually be the width, or is it the height? 6 and 4. So we have minus 3 till 1, and we have minus 3 or 4 till 10. Okay, so 6 is the width. We have from 4 to 10, and minus 3 to 1 is 4. The difference is 4. Just checking the difference. So if we take minus 3 and subtract the coordinate of the bottom corner, we get 4. The same goes here. We get 6. So first number is top. Second number is left. And the final two numbers are width, and this is height. Okay? Now, it seems that we did it correctly here. So we have width and height. And we can come here and we can define the isInside function. Right now, isInside returns always true. But we can change that. We can say, now, if the top left corner, so if the top left corner is smaller, or it's more to the bottom and more to the right of this corner, it means that the rectangle is actually inside the other. But we need to check this for all the corners here. And how can we do that? Well, first of all, we say something like this rectangle's top is, if this rectangle's top is bigger than other rectangle's top, or let's say smaller, and let's do it here, and this left is less, or yeah, less than other dot left, and this bottom is bigger than other dot bottom, or let's place equal signs. So I'll go through this and explain it in more detail just in a second. You can say, and this height is, or let's say, okay. Now the isInside function currently returns always true. But we can change that. And the way we need to do that is by using the coordinates of the top left corner of the rectangles. Now, the first thing is we can say if the outer rectangle has a left corner, or the x coordinate of the top left corner of the outer rectangle is more on the left than the inner rectangle, this is one of our conditions. So if outer left is less than this left, and the outer top is less than this top, okay, and we can see that here, and we can see why. So if this left, so if this point, basically if this point is somewhere on the left and on the top of this point, it means that the first condition is satisfied. So if this point is more on the left and more on the top than this point, the inner one, this is our first condition. And the way we check that is by saying, okay, is the y coordinate of this point bigger than this point? Is it? And we can check that. And is the x coordinate here, the x coordinate of this point, smaller than this point? Okay, so if x coordinate of this point is smaller than this point, this is one of the ways that we check whether the point is more on the left or more on the top. And we can do it here. So if outer left is more on the left and outer top is more on the top, and if the height of the triangle or bottom is bigger than the height of the inner triangle, bigger, and the width of the outer triangle, let's say right, is bigger than the width of the inner triangle, we should be ready to print the result. Why? Because if the corner of the inner triangle, the top left corner, is somewhere below and on the right of the top left corner of the outer triangle, and its width and height is less than the outer rectangle, sorry about that, it means that the inner triangle is really inside the outer triangle. And we can check that here. So we can say 4 minus 3, 6, 4, 2 minus 3, 10, 6. And we can see here it's inside. And let's recap briefly. In order to check whether a rectangle is inside another rectangle, we first need to check whether the top left corners align or one of the corners goes more on the left or on the top. And the second condition is that the inner rectangle has less width and less height than the original one. And let's try it again. So we have another example, 2 minus 3. So we have 2 minus 3, we have 10, 6, and we have 4 minus 5, 6, 10. And we have not inside. Okay, so it's not inside. This is basically the rectangle position problem. And reflect back on our solution, try to figure out how and why it works if you still didn't get it. Basically, think about intersection of rectangles as intersection of the top left corners and the width and the height. Good luck. The next exercise that we have to do is called sales report. And in this exercise, we need to collect data about sales, aggregate it, and output it to the console. First of all, we need to create a class called sale. And this sale class has a town, product, price, quantity, and we need to get all of this data, aggregate it, and output each town and its corresponding sales. So each town has different amounts of sales, and we need to print them out to the console. Now, I encourage you, this is not a complex task. Please try to do it on your own using a sales class or a sale class and something like a link or maybe a dictionary or whatever you prefer. Now, pause the video and try to do this exercise on your own. I assume you have tried to do it on your own. Now we are going to do it together. Now, let's create another class called sale. Called sale. And this sale has a town, public string town. It has quantity, public int quantity. It has a price. And we have a product name. Okay? Now, the thing is that here the product name doesn't really matter that much, but at the same time, let's just print it. So we have a product name, which is public string product name get set. Okay? Now we have the product name, the quantity, and the price, and the town. What we need to do is we need to read each sale from the console. Now let's clear this method and call it read sale or read sales, and let's return an array of sales. So a sale array. What we can do here is say, okay, I need you to read the sales from the console. So read sales. Let's create another method called read sale. And by the way, modularizing your solution this way will make it a lot more clear for you. So we can say read sales first read the integer, the number of sales from the console, and parse console read line, and we say take the next n sales from the console, e++. We can say okay, now on index e, sales, new sale. This is our container in which we're going to store the sales that we parse from the console. We say sales e is equal to read sale, and this should read the actual sale from the line, parse it, and give it back to us. And we can now return the sales array. Now, what we need to do here is we need to read a line. So we need to say string sale args. So it's a string sale args. You need to say zol read line, split the arguments of the sale by whitespace. And the first argument is the name of the town. The second argument is the name of the product. The third argument is the price, and the fourth argument is the quantity. So the same thing goes here. The first argument is the town name. So town name is sale arguments of 0. So this is the first argument. Product name is sale argument of 1. We have the price, which we need to parse from sale argument 2 or 3. And we have the quantity, which we need to parse from sale argument index 3. Okay? Now, what we need to do is we need to return a new sale and give it the town name, give it the product name, give it the price, and give it a quantity. So this is the way we read a sale from a console. And the same thing goes here. So we create an array of sales and we return it back to the main method. So sale, read sales. Now, what we need to do here is we need to aggregate this array of sales But how can we do that? Well, the thing is that we need to order the results by town name. So we need to aggregate for each town the number of sales that occurred there, or the total price, the total money that they got from the sales, and we need to order them by town name. So how can we do that? Well, first of all, we need to say something like console write line and say, or let's make it this way. So console write line join all the towns by a new line, and as a collection we're going to give this. So sales, we're going to aggregate for each town. So select x dot town, order by x dot select, or no, you know what? Let's make it a little bit more easier, or a little bit easier. So let's do it this way. We need to aggregate the town name, or let's create a dictionary which is going to be of string and double. This is the easier or the more readable solution here. So we have a dictionary of string and double. What we need to do is say this is the town revenues. This is the town revenues. I have a new dictionary. Let's make this one var. Now what we can do here is loop through the sales. So for each sale in sales, if the sale in sales, if sale is already in the dictionary, so if town revenues contains key the town of the sale, or let's say if it doesn't contain the key, add to the dictionary. Say town revenues, add sale.town, and 0 is a value. And we can say town revenues of the sale town, increment or add the sale price times the sale quantity. Okay, because we can have multiple towns, or we can have the same town, as you can see here, the same town can have different products. So each product has its own price and its own quantity sold. So we can have the same town with different products, and this will pretty much confuse our usage of link here. So we can say now for each entry or key value pair, let's say key value pair in the dictionary ordered by the town name, ordered by the key. Okay, so the key is a town name. This is why we are saying order the dictionary by key, because it's the town name, and we need the entries ordered by town name. We can say print, let's see, print the town, an arrow, and the quantity. And I guess we need to print it with some formatting. It doesn't really matter right now. What matters is that we get the actual correct results. So we have the key value pair key and the value. Okay? So we have the value and the key. Now, let's try and see what happens when we run our program. We have a little error here. We have some unexpected bugs. Okay, this one and this one. Okay, let's start program and see what happens. So we need 5. So we have Sofia, beer, and we have 1.2, 1.20, and 160. So we have Varna, we have chocolate, and we have 2.35. We have 86. We have Sofia, coffee, and we have 0.40, and we have 853. We have Varna, which is apple. We have 0.86, I think, and 75.44. And we can have Plovdiv. This shouldn't have happened. Okay, now what we can do is we need to do it again. So 5, Sofia, it's beer. We have 120, 60, I think, 160. Okay, we have Varna, chocolate. We have 235. We have 86. We have Sofia, coffee. We have 0.40. We have 853. We have Varna, apple, 0.86, 75, or we shouldn't be receiving actually decimals, but whatever. Let's just leave it. We're going to fix it later. So we have Plovdiv, and again we have beer, and it's 110, 88, 110, 88, and we get the incorrect result, and I'm pretty sure I know why. So this formatting here needs to be F2, not 2F, and we need to change this from int to double. Okay, so the quantity for some reason can be a double or a floating point value. So changing that, and if we go debugging again, we can see that we can say 5 Sofia beer, 120, 160. We have Varna chocolate, 235, I think it was. Yep, 86. And we have Sofia coffee. We have 0.40, and we have 75, or no, 853. We have Varna apple. We have 0.86. Okay, let's copy that. This is going to be a lot easier this way. Let's open a notepad. We have 0.86. We have 75.44, and we have Plovdiv beer. We have 110, 80, 88. Okay, so let's copy this, do this. We got input string was not in correct format. Yep, we need to double parse it here. So double parse, double here, and this should be okay. Do this, copy this again, and we get Plovdiv, which is 86.80, Sofia, which is 533.20, and Varna, which is 26 or 266.98. Let's see the result. Okay, so I think the result is pretty much the same. Yep, 96, 80, 533.20, and 26.698. So this is the actual solution of the problem. Now, what did we do? Well, first of all, we created two methods, one which reads a single sale entry and one which reads the whole entry from the console, all the entries. Now, what we did next is we aggregated each town in its sales. So we created a dictionary in which we kept the town as a key, and we increased every time, or increase the value every time we saw a sale. So every time we saw a sale, we increase the value. And each sale has a price and a quantity, which means that we need to multiply them. Finally, we order by town name, and we write it on the console. And this is pretty much the same solution as they did here. So they did a read sale static method, which reads all the sales, or reads a single sale, and they populated the object. They have also the read sales method, which reads all the sales, and it uses the read sale. Now, read sales uses the read sale method. And finally, what they did is they used extensively link in order to do the same thing which we methodically used, or which we solved methodically. Okay, and by the way, we could even use something called a sorted dictionary, which will just keep everything ordered by key in ascending order. But whatever, it doesn't really matter since we solved correctly the problem. Now try to solve even more problems using even more complex objects, and try to get out of your box and solve as many problems as you can. Good luck. Let's recap what we learned in this section. First of all, we talked about objects, we talked about classes, we talked about some APIs and built-in classes in C#, and how to create our own objects and classes. The first thing that we discussed is about the object. So what is an object? An object is just a set of named variables, a set of named values. Basically, you can have, let's say, an object called point. You can have 5 different point objects, all of them having the same 2 variables, and both of them named in some way. We can have point with coordinate x and coordinate y. We can have point with coordinate x, y, and z, point with coordinate x, y, z, and w, so forth, so forth. Now, what is an object? Basically, an object is a way to specify or what is a class? The class is a way to specify the structure of an object. So if an object is a named set of variables or values, the class is just a way to specify the structure of the set. So if we have a class called car, this car has some structure. This car class is some structured template. And from the structured template, you can derive many objects. You can have 5 different cars, 5 different car objects, all derived from the same car class. And the car class is just only one. Now, we also talked about some built-in classes and APIs into the C# language. One of them, which is called datetime. And datetime we used for parsing different dates, adding days, doing all kinds of stuff regarding or connected to dates. So whenever we were working with actual dates represented by a string, it was advisable to just use the datetime built-in class inside C#. We also saw how we can use the random class and how we can use the system numerics namespace, which defined the big integer. And the big integer we just used for huge number calculations. So we have these huge numbers and we just cram them together using the big integer. Now, what we also talked about is how to create your own classes and objects. So you could specify your own class by saying class, the keyword class, the name of the class itself, which here in this case is point, and this class has a body. In this body, you can specify different properties, you can specify different methods, different actions and behaviors, and you can make them either static or non-static. And we discussed what static and non-static means. Static means that the method or the behavior or the data, the variable, the property, is tied directly to the class and not to a particular object of this class. And non-static members of the classes are actually tied to the object, to the state of the object. So if you have a static member which is called cosine, like in the math class, which we also saw, a built-in math class, this cosine method was a static member. Why? Because we can calculate cosine on everything and the result will always be the same. So the cosine doesn't really depend on some mathematical or on some state of a mathematical object. It depends just on a single value, which it's way easier to create a static member. And for those that need to be dependent on the objects themselves, we just declare them as non-static members. And finally, we saw how we can create objects from these classes that we defined by using the new keyword. So using the new keyword, we instantiate the objects and use them for something. We have two different objects with different states, different properties, but both of them are of the same type. And this type is the class point. And one more way to think intuitively about classes and objects is that class is just a compound data type created by the programmer. And the object is just a variable of this compound data type. The same way we have integers is the same way that we have more complex data types that compact or that consist of many integers. And we can have variables of these more complex data types. Now, in order for you to grasp perfectly this content, you need to solve all the exercises that you're provided with, and at the same time, find even more to solve, and try to broaden your horizons. Try to think outside of the box. Try to practice what you learned in this section, and in no time, you'll master objects, methods, members, static, non-static, classes, whatever. So everything that we talked about, you'll be a master of it.